Hello students, welcome back to geometry. Today we'll be starting our lesson on 7.2 on parallelograms. Parallelograms are really interesting shapes. The idea behind them is really simple, but the implications of them are pretty big. So a parallelogram is simply a quadrilateral in which the opposite sides are parallel. So that means that in order to draw a parallelogram, I would draw two parallel lines that are connected by two other parallel lines. So that means this would be parallel to this, and then this would be parallel to this. That's the definition of a parallelogram, that the opposite sides are parallel. Now, before we move into the theorems that go along with this, I want to talk about something that we should be able to figure out just from that. So, let me move over here for a moment, and hey, there's a nice parallelogram. Okay, so if I assume that this is actually a parallelogram and the opposite sides are parallel, let's go ahead and put a number in there for now. So for example, let's say this is an 80-degree angle. Well, looking at the top and bottom lines, which would look like this, and then if I look at the left side as being a transversal, I see that these are consecutive interior angles. And we learned previously that consecutive interior angles are supplementary. So that means that if this bottom left angle is 80, that this upper left angle would have to be 100. Now, I can do the same thing going around the parallelogram. If I say these two sides are parallel and this is the transversal, well, this would have to be supplementary to this. So if the upper left angle is 100, then the upper right angle would have to be 80. And then using that same logic, we see that the bottom right corner would also have to be 100. So here's two things that I want to point out here. Using our vocabulary from chapter 3, we can see that no matter what the angles are to start off with, the angles that are directly next to each other, like that, if you pick any two angles that are directly next to each other, any two consecutive angles, they're going to be supplementary. They're going to add up to 180 degrees. Now, on the other hand, if you look at the angles that are across from each other like that, those angles are going to be congruent. So that brings us to the parallelogram consecutive angles theorem. And that is simply any two consecutive angles in a parallelogram are supplementary. Following that up with the parallelogram opposite angles theorem, opposite angles of a parallelogram are congruent. Okay, now that we've talked about the angles of a parallelogram, I want to talk about the sides. So here's what I'm going to do. I'm going to go back over to this picture here. And let's go ahead and take the numbers out and replace them with symbols. So I'm going to say this angle is congruent to this angle. This angle is congruent to this angle. Well, what I can do here is say, I'm going to go ahead and draw a diagonal in here. Let's switch colors. Okay, so now if I look at this as, sorry, I'm going to adjust that, these two sides being parallel lines with this orange transversal coming through, knowing that these two lines are parallel, that means that I can say that, I'm going to switch colors again, this red angle right here has to be congruent to this red angle right here because of alternate interior angles. So I can say this angle is congruent to this angle. And hopefully you're seeing what I'm about to do here. I've got two angles that are congruent because of the parallelogram opposite sides theorem. I've got two angles that are congruent because of alternate interior angles, and I've got this orange transversal that's congruent to itself by the reflexive property. So that means that these two triangles that I've created right here are congruent, and then using CP/CTC, that means that these two sides have to be congruent and these two sides have to be congruent. All that to say, if I know that a shape is a parallelogram, I also know that the opposite sides are congruent. So we can go to the parallelogram opposite sides theorem, which states that the opposite sides of a parallelogram are congruent. Okay, so one more, the parallelogram diagonals theorem. So I'm going to go ahead, I'll draw a brand new parallelogram for this one. And I'm going to mark in all the stuff that we know already. I know that this side is congruent to this side, and this side is congruent to this side. And I know that this angle is congruent to this angle, and this angle is congruent to this angle. Now what I want to know is something about where the diagonals cross each other. Marked poorly. So basically what I want to do here is show that I have some congruent triangles here. So what I'm going to do is mark here. Okay, I've got this side. Let me switch colors once more. This side, I said red. This side is congruent to this side. And then I can also say vertical angles. This angle is congruent to this angle. And then using alternate interior angles, I can say this angle is congruent to this angle, which means by angle, angle, side, these two triangles are congruent. So that means that using CP/CTC, this side would have to be congruent to this side, and this side would be congruent to this side. Now what we see here is where the diagonals intersect, I have congruent pieces on both sides, which means I'm going to draw this picture on its own. If I have the diagonals, this piece is congruent to this piece, and this piece is congruent to this piece, which makes this a midpoint of both diagonals, which means the diagonals are bisecting each other. So the parallelogram diagonals theorem simply states that, the diagonals of a parallelogram bisect each other. Okay, so let's do some simple examples. Find the values of x and y. Well, this one's pretty straightforward. If I look at x, I can say that 2x and 50, these are opposite angles. So I can say that 2x is equal to 50 because of the parallelogram opposite angles theorem. And then I can just divide by 2 and get x is equal to 25 because of algebra. Okay, for my second one, I see y plus 3 and 18. Those are directly across from each other, and I know that opposite sides of a parallelogram are congruent, so I can go ahead and say y plus 3 is equal to 18 because of the parallelogram opposite sides theorem. And then I can just subtract 3 on both sides, and y is equal to 15, and we're done because of algebra. Okay. Moving on, let's do a proof. So, A, B, C, D, and G, D, E, F are parallelograms. So prove that angle B is congruent to angle F. Let's get a little closer here. I want to prove that angle B is congruent to angle F. So I'm going to say, step 1, A, B, C, D, and G, D, E, F are parallelograms. That is given. Okay, so now, since they're parallelograms, what I want to say is that this angle is congruent to this angle. And by a similar argument, I can say this angle is congruent to this angle. So I can say, step 2, I'm going to have to write for this one, but we'll say angle B is congruent to angle CDA. And in the same step, I can also say angle F is congruent to angle EDG. And that is because of the parallelogram opposite angles theorem. Now I want to focus on these two angles right here, because what I notice is I've got some vertical angles set up right there. So I can say for step 3, angle CDA is congruent to angle EDG because of vertical angles. So now, hopefully you're seeing how we can line that all up. I can say step 4, angle B is congruent to angle CDA, which is congruent to angle EDG, which is congruent to angle F. And then, since all of these are congruent, I can just jump straight from angle B is congruent to angle F, and that is called the transitive property.